Now for this stage we're going to consider what we've been doing and think about it in the context of remainders. So let's give an example. If I've got 39 divided by 7, that equals 5 with remainder 4. And that's because we can write it in this sort of format. So 39 equals, that's 7 that it was divided by, so it equals 7 times 5 plus 4. And that's what we mean when we talk about remainder. Now we've been doing an equivalent of this, so if I take an example from before, if I start with this cubic expression here, I can take x plus 2 out of it, end up with a quadratic expression, and have this remainder of 1 left over. So if we were to find the analogy to this first instance, if I've got the cubic expression divided by x plus 2, then it's going to equal this quadratic expression with remainder 1. So when we've taken this factor out, the thing that's left over is the remainder of the original function being divided by that factor. And we're going to use that to try and derive something called the remainder theorem. I'd like you to start with this polynomial. So it's a cubic expression. And what I'd like you to do first of all is divide by x minus 2 and then find what the remainder is. After you've done that, I'd like you to calculate what p of 2 is, i.e. if I substitute 2 into this expression, what answer do I get? Now, repeat the process by dividing by x plus 1, find the remainder, and then I'd like you to calculate what p of minus 1 is. What are you noticing? Try some different values to experiment. There's a result there that I'd like you to find and state for me. As the extension, and this is degree level stuff, can you prove the result? Can you prove that it is always true?